Now that our project is set up and ready to go, let's set up the player game object. First, I'm going to make sure that I'm in the scene view for the best view of the scene we are working with. Next, I'm going to add the player's ship model. We can find the player's ship in the Assets folder in the Models directory. Drag the vehicle player ship from the Models directory into the Hierarchy view. We can also drag this model directly into the scene view if we choose to. Either way is correct. Let's get a better view of the model in our scene. To do this, we want to focus or frame the selected game object with the scene view camera. We can do this by either choosing Edit, Frame Selected, or by using the hotkey F while the pointer is in the scene view. Double-clicking on the game object in the Hierarchy view will also focus the scene view camera. There's our player ship. Now that she's in the scene, let's rename her in the Hierarchy. Click on the game object in the Hierarchy and type either the Return or Enter key to enable editing. We can also click on the game object twice, slowly, to enable editing as well. Name the game object Player, and then hit Enter or Return to confirm that change. We want our player ship to be at Origin. Origin is the center of our three-dimensional scene, where the X, Y, and Z coordinates are 0, 0, 0. Let's use the context-sensitive gear menu in the upper right of the transform component and select Reset. This will reset the transform's position, rotation, and scale. Now we have guaranteed that the model is placed perfectly at origin. We want this ship to fly around, fight enemies, yet be vulnerable enough that we can be destroyed if we're not careful as we pilot our ship. We currently have nothing more than a mesh model that represents the player in our scene. The game object that holds our ship has a number of components that define what our ship is and where it is in the game. The game object uses a mesh filter to hold our mesh model, and a mesh renderer to render the ship in our scene. The renderer references two materials, shown here at the bottom for our convenience. The game object uses the information in the transform component to know where the model is in the game, what direction it is facing, and what scale it currently is. To set up our player game object, we will be adding more components that perform specialized functions, and we will be creating our own components using simple scripting. We will be moving our ship using physics, though in an arcade style, and we need physics to detect our collisions between the player and other game objects in the scene. To use physics, we need to add a rigid body component. I'm going to quickly reduce the view of these referenced materials by clicking on the header bars, so that it's easier to see and access the Add Component button without scrolling. Now, let's click on Add Component and select Physics, Rigid Body. This attaches a rigid body component to our game object. By default, the rigid body assumes we want to use gravity. And, well, we're in space, and we don't want to fall out of the game. So let's deselect Use Gravity. With the rigid body attached, our game object now uses the built-in physics engine. To detect collisions, the physics engine, through the rigid body, needs to know the volume of our objects. We need to know how much space these objects take up in our game to calculate the collisions. We give this information to the rigid body by using a cage that we wrap around our game objects. This cage defines the volume of that object. The cage is called a collider. Let's use the Add Component button again. This time select Physics, Capsule Collider. This puts a simple cage around our player game object. This looks like a sphere, but that's because a capsule collider is defined by two spheres and the space in between them, and we are seeing both spheres in the same place. Let's change the capsule collider's size. The default orientation for a capsule collider is up and down, or along the y-axis. This is to fit a humanoid object. Our ship is longest along the z-axis, so let's change the direction to z, and reduce the radius and increase the height. For a better view, let's change our orientation. For a top-down view, let's click on the Scene View gizmo. and click on the Y arm. In this view, it's easier to fine-tune the shape. We simply need to choose the values for radius and height that comfortably fit the collider to our model. Now, for the purposes of this game, which is fairly simple, the capsule collider is sufficient. There are other alternatives, however. Let's click on the Add Component button again and select Physics. There is the Box Collider and Sphere Collider as well. The Box Collider and Sphere Colliders are two other primitive colliders like the Capsule Collider. But there is a more complex collider called a Mesh Collider, where we can supply the collision mesh ourselves. For more information, see the documentation on colliders and the lesson on colliders linked below. At this point, I think it's important to note that the primitive colliders, the box, sphere, and capsule, are far more performant and should be used whenever possible over the mesh collider. For more information, please see the Compound Collider section of the rigid body documentation linked below. If, however, we have a more complex shape that can't be accommodated by any of the primitive colliders, and for some reason doesn't work by using a compound collider, we can select Mesh Collider. Let's look at the Mesh Collider in action. Select Mesh Collider and, yes, replace the existing component. This will remove the Capsule Collider and use the Mesh Collider instead. To have a better look at the Mesh Collider, let's turn off the Mesh Renderer. This reveals the green lines of the Mesh Collider that were hidden underneath the rendered mesh. We can see how complex this cage is. Unity must check the position of each triangle in the cage relative to the other colliders in the scene to properly detect a collision. If for whatever reason we use a mesh collider rather than a primitive collider, it is best that we use a simplified mesh. The mesh collider holds a reference to the mesh it's using in the mesh slot on the component. By default, Unity will use the mesh in the mesh filter if one is present. We can simply swap this out with a new simplified mesh of our choice. We have supplied a simplified mesh in the Models directory. Open the model file and select the mesh asset. Drag the mesh asset into the mesh slot on the mesh collider. Now we can see the substantially simplified mesh being used as the collider. Let's turn the mesh renderer back on. For the purposes of this game, we could use a capsule collider, but this game will be simple enough to absorb the larger cost of the mesh collider, so let's leave it as it is. Now that we have a working collider, we need to adjust the collider's settings. For this game, we don't need to or want to detect full physics collisions. We simply need our collisions to trigger an action. So, select Is Trigger, making this a trigger collider. Lastly, let's add a little sizzle to our ship. In Prefabs, VFX, Engines. There is an Engines player prefab. Let's add this to the player ship. Drag the prefab onto the player ship in the hierarchy to add it as a child game object. The Engines prefab consists of two particle systems. Now, they look funny in the scene view, as the particles are billboarding or facing to the camera at all times. If, however, we are in top-down mode, like our game will be, they look just fine. If the gizmos in the scene are too large, we can reduce them by selecting the Gizmos button in the Scene View toolbar and adjusting the slider. Now our player ship is set up. In the next assignment, we will set up the camera and the lights.